it's Mr. Van Dong here again with week 3, day 5 of our distance learning. And today we're going to learn how to convert anything in the metric system. Anything with one system in the metric system. It's the best. So today you can cast your math book aside. You do not need it. You do want a sheet of paper. So you can pause the video and get a sheet of paper, a pencil, and then come right back. Are you back? I hope you're back. You should be back by now. So we're going to need to be able to make this chart. And I can see already that the blue may have been a bad choice. But whatever, you can listen and you can watch. So we have to remember a short little story. And then from there, we'll be able to convert anything at all in the metric system with incredible ease, because it works just like multiplying by 10 and dividing by 10. When you multiply a number by 10, the decimal shifts once to the right to make it bigger. And if you divide by 10, then the decimal would shift once to the left to make it 10 times, or a tenth the size to make it smaller. So that's all we have to do. We just always have to shift the decimal in one direction or the other. Yesterday, you may have noticed that with kilograms and grams, that it was always shifting the decimal 3 times in one direction or the other. 1 gram, 1,000 grams became 1 kilogram, for example. 1 kilogram becoming 1,000 grams. So the same thing, they're equivalent. So this conversion process is super good. Just to make sure we're totally clear, and when I say converting units of length, converting units of capacity, converting any type of measurement unit, we're talking always about converting it to an equal amount. So it's not like 6 feet compared to 12 feet. It's like 6 feet is the same thing as so many inches. They're equivalent. They're the same. And that's what we're doing with metric system, and it's the best. So time to memorize a story. It's about King. And all it is that, I might be off screen for a hot second. King Henry died. Oh my goodness. Unexpectedly. Oops, I need an N. Unexpected. Okay. King Henry died unexpectedly drinking chocolate milk. If you can remember that silly little story that King Henry died unexpectedly drinking chocolate milk. This is going to bother me. Unexpectedly. Now it's perfect. So, King Henry died unexpectedly drinking chocolate milk. Mr. Van Dong, is that true? No, it's not. It's just to help us remember, okay? King Henry died unexpectedly drinking chocolate milk. We remember that only for the first letter of each word, so that we can write down KHDUDCM when we're solving problems involving the metric system conversion. So all we really need is KHDUDCM. They don't actually stand for King Henry died unusually or unexpectedly, whichever one. People say both. Drinking chocolate milk. It's just a way for us to get those letters up there. So I asked you to get a sheet of paper. So I want you to maybe pause the video, and if you've not already written this down, pause it and write it down now. See if you can write down that from memory. Don't peek. Did you do it? I hope you did. I hope that you were able to write down King Henry died unexpectedly drinking chocolate milk, or at least think that in your head and write the letters KHDUDCM. Now, why do we do this? The metric system was designed with science in mind, and it was designed with our base 10 math system in mind, and it works out wonderfully. Every type of measurement has a base unit. So the U stands for unit. Every type of measurement has a base unit, and we've already talked about 2 of them. If we're measuring a distance, a length, our base unit is 1 meter. Our base unit is 1 meter. So I'm going to write here, meter. I should have written it in lowercase. You'll find out why later. Okay, base unit of length is meter, and that's abbreviated m, lowercase m. Okay. If we're measuring mass, like yesterday, our base unit is a gram, which is abbreviated with a G. And if we are measuring capacity, which we didn't have a lesson on that, but remember capacity is how much fluid will fit in something, then we measure it in liters. A liter is the base unit, and that is a capital L so that it doesn't look like a 1. So our base units are meters, grams, and liters. So I think you already know this probably. So if we're talking about measuring something with meters in it, length, something, how much mass there is, or how much something weighs on Earth, grams, or how much fluid fits in something, a liter, like a 2 liter of root beer or whatever. So yes. Now, all of these other letters just stand for prefixes. They just stand for prefixes. So for example, we already might know what this one is because yesterday we were talking about kilograms. So the K stands for kilo. Okay, so there's kilo, and so that would be kilogram. Have you heard of kilometers? You have. Oops, I put the kilo in the wrong place. I should have put it up here. It's kind of my first rodeo in a while. Singing a song while I erase the thing. There we go. Kilograms, kilometers, and do you think there's kiloliters? 100% yes. Kiloliters. Kilo. Kilo literally means 1,000. You know how many meters there are in a kilometer? 1,000. How many grams there are in a kilogram? 1,000. How many liters there are in a kiloliter? 1,000. It's always 1,000 because that's what kilo means. It's the coolest thing, right? Okay, so what are the other ones that are up here? What's the H going to stand for? H stands for, oh, I don't want to lie to you. Give me a second. I think it's hecto. Yep, it's very realistic. Mr. Van Dong running to fact check himself. Feel like you're right back in class. So hecto. And hecto literally means 100. So we don't usually use something like a hectometer, but there is such a thing as a hectometer. There is such a thing as a hectogram. There is such a thing as a hectoliter. And guess how many grams there are in a hectogram? You don't have to guess. It's 100. All of these are 100. Hecto literally means 100. That's just what it means. It's probably in Latin. I don't know. You can look that up and tell me. So we've got, if there's 100 of the thing, it's a hecto whatever. Now what's the D? What do you think? If you're thinking deci, then you're pretty close. But it is actually Deca. It's Deca. And I can't remember if it's a capital D or a lowercase g. I better check. I don't like lying to children. The abbreviation is DA. Okay, so a decameter. Mr. Van Dong wrote a bad word on the board. No, he didn't. It would have an N at the end if it was. And there's a decagram, and there's a decaliter. How many meters to make a decameter? 10. Deca just means 10. Okay, so a decathlon. Right? Anyway, so 10. 10, 100, 1,000. Base unit, just normal. Okay, now we're getting to smaller than 1 whole. So this is 1/10. Right here we have 1/10. And that D, I believe, is deci, but again, I don't like lying to children. Yes, it is deci. Good. Deci. Okay, that kind of looks like CL. I'm guilty of that sometimes. So deci. So a decimeter, a decigram, and a deciliter. It would take 10 decimeters to make a meter. So in my hand, I'm holding a meter, and this is the length of a decimeter, 1/10 of the whole meter. So deci means tenth. That's why the decimal system. You got it. All right, this one I think some of you may have known. We've used this. We use this for measurement. This one was centimeters, right? So we've got centi. Centi means hundredth, centimeters, centigrams, centiliters. It would take 100 centiliters to make a liter, 100 centigrams to make a gram, 100 centimeters to make a meter. Centi just means hundredth, because 1 centimeter is 100th of a meter. Okay, and last but not least, M stands for milli. Okay, so a millimeter, a milligram, and a milliliter. Now that's a lot of information. It feels like, well, Mr. Van Dong, do you want me to memorize how to make this whole chart? No, I didn't say that. I need you to memorize King Henry died unexpectedly drinking chocolate milk. I want you to know why this chart works. It's really important to me that you don't just think of math as like a magic spell, but that we're building an understanding about why all this works. In the end, our ultimate result is, if you're converting something, you may have noticed these steps down here. If you can write this down, you're going to put your finger on the type of unit that you want to end up with, and then count how to get there. And that's all you have to do for the conversion system. So I'll show you an example in a second. But I also want to point out that most of these words up here that I've said, you've never heard of before, because they don't really get used. I'm going to circle in red the ones that we actually use in every system. So for meters, we really do use kilometers, and we really do use meters, and we really do use centimeters, and we really do use millimeters. But nobody really ever talks about the other ones. We still need places for them up there, but don't be like, oh my gosh, I have to memorize these things. Those are the ones that we'll use for length. Those are the common ones, okay? For mass, we use kilograms, we use grams, and we use milligrams. All of the other ones, they're just not used that often. We don't really need those other ones for anything. It's possible we could use them, but we're not really responsive. You don't have to like have it memorized. Oh, DG is decigram, and it's DAG for decagram, and what's the difference? Don't worry about it. Okay. And for liters, for capacity, we obviously need the base unit. We know liters, and then we just need to know what milliliters are. And we don't really measure anything in kiloliters. So just liters and milliliters. So you can see here probably a bit of a pattern. The most important thing, understanding what the unit is, we always use the milli version. We almost always use the kilo version. And in one particular case, we use the centi version as far as what's commonly referred to. So let's do an example problem. First of all, you're welcome. The math today is way shorter. And the homework is way shorter too tonight. All we need to be able to do is let's do a couple of problems. Hey, I totally just realized I botched the directions that I wrote down here, and I'm not going to reshoot the whole making of this. So I'm drawing your attention in red just in case you're like, oh, I read what was on the board and memorized it. It was backwards. So we're going to do an example problem, and I want to just draw your attention to what was wrong. So anyway, so let's try using the chart. So what we need to do is have a problem to start with. Let's say that we've got something like 8 grams, and we're trying to figure out how many milligrams that is. Okay, to solve this problem using this method, using this chart, I need to be able to write just the first letter of King Henry died unexpectedly drinking chocolate milk, and then I need to put my finger on where I'm starting, the unit I'm starting with. I'm starting with grams, which is the unit. So if I just wrote down the letters, I'd be pointing at the U, but I'm going to use the overall chart because I've got it up here and I want to help you. with that way. So I point at the grams. I'm starting with grams. And I need to think, well, where do I want to go? I need to go to milligrams. How would I get there? I would go to the right 1, 2, 3 times. Well, guess what happens to the decimal in 8? It shifts to the right 3 times. Super easy. So the invisible decimal in 8 shifts to the right 1, 2, 3 times. 1, 2, 3 times, and I need to annex the zeros in there, and I have 8,000. 8 grams is 8,000 milligrams because it takes 1,000 milligrams to make 1 gram. So we can solve that without having to stack or multiply or divide or anything like that if we use this method. So we point to where we start, and then we count where we're going to go to, and then you're Gucci, as somebody once said to me a long time ago. Now I've said it to you. So let's do another one. Let's imagine, so we did one where we started with grams and then we went to a smaller unit. Let's imagine we're starting with a smaller unit and going to a larger unit. Let's say that we're starting with just a cool 2 million millimeters. And I want to know how many kilometers that is. Okay? I'm starting with millimeters and I need to go to kilometers. And then I count how many jumps it takes to get there as I move to the left. To the left, to the left. 1, 2, 3, 4, 5, 6. I need to shift my decimal 6 times to the left in my 2 million millimeters. 1, 2, 3, 4, 5, 6. Okay, that's 2 kilometers because I shifted the decimal over here. There are in 2 million millimeters, that's the same thing as 2 kilometers. Okay? Again, you don't have to be able to reproduce this entire thing from memory. You need to be able to reproduce this from memory. On that last problem, I would have gone, oh, I'm starting with millimeters, and I'm going to kilometers. So I start here, I go 1, 2, 3, 4, 5, 6. I'm going to shift 6 to the left to get the right answer. So I wanted to show you the chart. I wanted to refer to the chart. I want you to be aware of the chart, know why it works. But bottom line here is we shift the decimal to the left to make numbers smaller by multiples of 10, or to the right if you're going to make them bigger by multiples of 10. And this chart will help you solve any metric measurement problem. You can go straight to the math choice today. There's not a regular math assignment as my gift to you before the weekend. And your homework's a little shorter tonight too. So I will see you guys later. Hey, good week. Week 3 done. Almost. You got a little bit more work. I'm done. The YouTube version of me is done. I'll see you guys later.